This is Bill Calero from the virtual world here at Microsoft. I am the product manager for Cloud PKI, and with me I have my collaborator and partner in crime, Jack. Jack?
Hey, Bill. Jack Pullman here. I'm a principal product manager. Work closely with Bill and have been on the journey for Cloud PKI since its inception. So great job, Bill, in getting this thing out in the world for us.
All right. So the title of our talk today is how to utilize, configure, and manage Cloud PKI like a pro. Hopefully, this is a deep dive session. Hopefully, I can give you some good insights and a few tips that can help you navigate the Cloud PKI service. All right. With that said, let's kick things off. The agenda for our talk here is I'm going to cover some fundamentals. I always think it's super important to level set folks on what Cloud PKI offers today. I will get into a relatively new feature that we surfaced a few months back. It's called deleting a certificate authority. Provide some guidance on how to do that. Support gets a few questions sometimes and they require assistance. It's all documented, but it's always good to see it firsthand in a demonstration. I'll talk about some of the particulars around the SCEP certificate profile that are related to Cloud PKI. Then we'll talk about something that often comes up from customers requesting additional assistance. And this is around the Microsoft Network Policy Server service. It's a radius service for connecting to either, you connecting it to Wi-Fi or VPN, things of that nature. And then we'll give you some insight into what's coming later in the year. All right. With that said, let's push it along. Fundamentals. So first and foremost, let's just talk about what Cloud PKI can deliver today. Right. We released in March of 2024. Cloud PKI can issue certificates, client authentication certificates, for any of the Intune set of managed and enrolled devices. In particular, the Windows platform, iOS, Mac OS, Android. You'll see that Linux is not supported here, and that's because the Linux platform, doesn't have support for what's called the SCEP certificate profile. Anything within Intune that has support for the SCEP certificate profile, we can issue certificates for.
So wait a minute, Bill. I don't see NDES on this slide anymore. Do I need an NDES server with Cloud PKI?
You do not need an NDES server. That's right, Jack. So it's part of the beauty of Cloud PKI. So you see that second bullet point there. It says that we provide a certificate registration authority to deploy certificates via the SCEP protocol. If you've ever deployed NDES in your environment, you know that it could be a painful experience. A lot to configure, a server to configure, firewalls to configure. We removed all of that, all those challenges and overhead with the cloud-based Cloud PKI service, which is wonderful.
And everybody I've talked to tells me that, gosh, you guys landed that. So good job.
Good job. Obviously, with Cloud PKI, just like we offer today with the Intune certificate connector, it's essentially we manage the full lifecycle for certificates, right? We automatically deploy certificates to the set of enrolled and managed devices. We support, as I said before, the full cert lifecycle. We issue the certificate when it's due for renewal. We renew the certificate when you unassign profiles or you remove devices from the Intune service. We remove the certs from the device and we revoke the certificates accordingly. And we also support the ability to manually revoke certificates now with Cloud PKI. It's pretty sweet. Obviously, there's all the reporting and monitoring that you can see in the Intune console. We provide a series of metrics around the number of certs that are active, what's been revoked, what's been expired, et cetera. And we can give you some detailed reports when you could go into what's called the Leaf Certificate Report. Within the issuing CA, you'll see all your certificates. You can search for them. You can search by serial number, et cetera. It's all there for you to take advantage of. And of course, these certificates are primarily used for what's called certificate-based authentication. We call them essentially the family of resource access policies that Intune has. So that would be email profiles, Wi-Fi profiles, VPN profiles. You can even deploy certificates for Windows Hello for Business. You can deploy certificates for client auth to authenticate to your on-premises applications or even the M365 set of applications. So it's a full gamut of SERP-based auth, obviously.
And Bill, is that for all of the platforms kind of listed above? Can I do it for my Apple iPhone?
Absolutely, Jack.
Nice.
All right. Again, some of the immediate benefits, and again, I'm just covering the fundamentals here and level setting here. So, as Jack mentioned, there are no NDES deployments for you to set up, right? You don't have to procure servers for your NDES environment. You don't have to talk to your firewall team to poke holes to that firewall. You don't have to set up any kind of reverse proxies anymore. You really reduce the overhead on your on-premises certificate authority infrastructure, right? All of the issuing of certificates for the set of Intune enrolled and managed devices, that workload essentially gets shifted and moved off to the Intune service in the cloud. It's really it's a huge advantage, right? And you can literally stand up this PKI service in 5 minutes or less. Once you're familiar with the console, you know what steps to click. You can literally stand things up and start issuing certificates in 5 minutes. I mean, I've done it. I'm sure, Jack, you've done it. So,
I was going to say, Bill, 5 minutes is almost slow in my experience. It's more time in figuring out what am I going to name my certificate authorities and things like that. The actual work in the console is, 30 seconds for a root CA and another 30 seconds for an issuing CA, and it's more of how fast I can type.
Yeah. No, it's a good point, Jack. I don't want to exaggerate too much, but it is pretty straightforward and very simple to deploy. Which again, that's what we were shooting for. And and the other thing is not only easy and fast to set up, but the issuing of certificates themselves are pretty quick as well, right? We see great performance there.
Yeah. Well, and in additional things like publishing of a CRL is something that a lot of people with an on-premise environment may not have, and it's just inherent with Cloud PKI of the revocation list being accessible on the public internet.
Yep, and don't forget the AIA, the Authority Information Access Endpoint as well.
Similar. Yep.
Delivering the intermediate certs, right, when you don't have them, right? Again, major benefits. All right, let's push on. A few things since we GA'd, general availability back in March, as I said. So we added this ability to delete a certificate authority. When we first released, you didn't have that ability, and so if you wanted to delete a certificate authority, you had to make a support call, create a support ticket, and then have the support folks, integrate, talk to our engineering folks and have those certificate authorities get removed from the service. But that is all now in the customer's hands, which is great. And so I will walk you through that process as well. It's pretty well documented. The other thing is that
So, hey, Bill, what if customers were trialing Cloud PKI and they bought it? Is this a critical capability for them?
Well, if you're trialing it, you can create up to 6 certificate authorities. When you create a trial, you're actually using what's called software keys for your encryption and signing keys for each of the CAs. When you have what's called when you're licensed for Cloud PKI, you're actually using an HSM service. We back the signing and encryption certificates of each of the CAs with managed HSM from Azure, which is 140. FIPS 142 level 3 certification for HSM, which is fantastic. And again, that's just an inherent benefit of Cloud PKI, no additional, pay for service for that HSM service.
So if a customer is moving from a trial to a purchase license, they probably want to delete their trial CAs, create new ones. All right.
That is, you brought me back to the point of the initial question, which is, why do you want to delete them? So again, if you create a trial, we can't take your trial CA, which is using software keys, and essentially migrate that over to HSM. You have to essentially, you can continue to use your trial CAs using software keys, but a lot of customers, either they want to get rid of that and start creating new CAs, and so they don't want to, tap into their 6 CA limit. If a customer needs more than 6 CAs for whatever reason, they should call support to essentially rationalize that scenario with us, and we could essentially, in certain cases, we can generate new CAs for them, or give them the ability to add a new CA.
That's a very conscious limit on that, right, Bill?
Yep,
And
absolutely,
something
because of the
that
HSMs, right? We have
okay.
that's a finite resource within Azure, and
So
so
if I want thousands of certificate authorities, I better have a lot of really good justification.
100%.
Okay.
The next thing is in terms of automation. A lot of our customers like to automate either the issuing of doing some reporting behind certificates, or maybe issuing certificates for certain scenarios. And so the ability to have what's called an Entra ID app registration object within their tenant, that's relatively common today with a lot of our third-party vendors, and so who manage big Intune tenant environments. And so there are actually two types of Graph API permissions associated. There's something called delegated permissions and app permissions. Delegated permissions essentially is an application. When you create an application, it still needs access as a signed-in user. The API needs access as a signed-in user. And that's available today. But the other one that's a little more challenging and requires some additional code work is something called app permissions, where essentially you are going to create an application that runs as a background service, a daemon, without a signed-in user. So that one requires a little more security oversight. And so that's taking a little longer for us to get out the door, but it is coming soon. Don't have a specific date to share, but that is coming. And then I posted a link here when this slide deck becomes available in terms of how to create, app registration and graph permissions. So I think that's always helpful. All right, so let's talk about how to delete a Cloud PKI from within Intune, and some what I think is some good guidance. It's all, again, documented online, but it's always good to see things up front. So follow the process. All right, so I've mapped it out here into 3 steps. Obviously, there are a few sub-component steps to this, but the first thing you're going to want to do is you're going to want to pause your certificate, your issuing CA, right? And then what you're going to do is after you pause it, you're going to want to remove any of the resource access linked profiles to the certificates, right? So if you've got SCEP certificates that are connected to that issuing CA, or using the SCEP service from the issuing CA, you're going to want to remove those assignments, because a pause CA will not issue any new certificates, right? The CA itself can honor revoke actions. It will update the CRIL. It will respond to CRIL requests or AIA requests. But in terms of issuing certificates, a pause CA will not issue new certificates, right? And so you don't want to get errors in your console for a SCEP certificate profile that's still assigned to an issuing CA and assigned to a group trying to issue certificates. You're just going to get errors.
So, Bill, what if I change my mind after I've paused it? Can I unpause it?
Absolutely, 100%. You just
Okay.
click the unpause button and you're back in business.
Beautiful. What about after? I'll ask you again after revoke here. I'm curious.
Okay. So the next thing you're going to want to do is you're going to want to revoke all of the leaf certificates that issuing CA issued, right? And so we actually give you, if you have a large number of certificates, we provide, again, through the online documentation, a sample PowerShell script that will connect to the graph. You have to sign in with the proper credentials that has access to that respective CA, and then that will automatically essentially walk through all of the revocation of the certificates. And then once those certificates are revoked, all of them must be revoked. You can then go ahead and delete that issuing CA from the console, right?
So can I back up if I've done the revoke?
Once you revoke, you revoke. There's no unrevoking a certificate.
Okay. But I could put the CA back into play. All the revoke certs would remain revoked, and I could issue new certs before I.
That is correct. Let's just say you went through, you paused your CA, you then went ahead and started revoking all the certificates. Those certificates that were revoked are revoked. And now you say, oh my God, wait a minute. I don't want to continue with this process. I don't want to revoke the issuing CA. So now you can unpause the CA and the CA is back in action, right?
Fair enough.
But once you revoke, so the first thing is you're going to revoke, pause the CA, revoke your leaf certificates, and the next step that you would do is you're going to revoke the actual issuing CA. Now, when you revoke that issuing CA, if you actually go through the action, and revoke the issuing CA, that's it. You can't go back.
All right. So this delete action, you're telling me that's a one-time thing. Once I do that, I'm done. But steps 1 and 2, I could.
Well, not exactly. Let me just say that one more time. Okay.
Okay.
So in the revoke step number 2 that we've got here, right? You've got once you revoke your leave certificates, the next thing to do is revoke the issuing CA certificate.
Oh, gotcha.
Right.
Okay.
Now, if you revoke and you go through and you actually revoke the issuing CA certificate, you can't go back.
Gotcha. All right. Fair enough.
Yeah. Deleting the CA just essentially gives you the ability to create new. You're removing it from your Intune tenant permanently, right? But you can't go ahead and unrevoke that issuing CA. You're gonna have to just create a new issuing CA.
All right. So I've been warned. I can
warned.
Can do 3 of the 4 steps without and go back. But once I go past that, revoke my issuing.
Yeah,
I'm done.
2.1 of the steps, not 2.2 of the steps.
Fair enough.
All right, let's keep going. I actually recorded the demo because there are a lot of steps, and once you do it, you can't undo it. So I'm going to attempt to walk you through my process here. So I'm going to Cloud PKI. I click on my issuing CA. I see that I've got 4 certificates. First thing I'm going to do is I'm going to hit the pause button, right? So I click pause. I get a message here that says, before you pause the CA, make sure you remove all of your resource access assignments, right? SCEP, Wi-Fi, etc. Right? So now I have another tab here. I've got my 2 SCEP certificate profiles. I am going to go to each one of them and remove the assignments. I don't have to delete the SCEP certificate profile, but I should remove the assignments. Why? Because the CA is paused. It's not going to issue certificates in a paused state. So I remove that assignment. I go to the next SCEP certificate profile. Coming up in a second. All right. Click on it, and I will then go to my assignments, and I will remove the one group assignment that I have as well. And I will save that, confirm that it's successfully saved. And now I am sure that I've removed my assignments. And now I'm going to go ahead and fulfill that action. And I am pausing the CA, right? And it's successfully paused. I'm going to click on the issuing CA. All right. And then I think, you know what? I didn't refresh it. Let me go back. I want to refresh to make sure that it's actually in a pause state. So I see that the status is paused. I want to show everybody that action did take place. Right now, I'm going to go view all certificates. I've only got 5 certificates here. One of them is already revoked. So I'm going to open up my PowerShell session. I'm going to launch the script. Right. Again, I downloaded the script. I saved it onto my desktop. And now I'm going to run the script. The script is going to ask me for the issuing CA ID, right? And I have it right up on the top, and I'm going to just copy that CA ID right from within the Intune console address bar. I then paste that into the PowerShell script or my PowerShell console script, and I hit the enter button, and I'm going to get prompted to authenticate. It's going to say, hey, you're going to have to download some graph modules. And once you do that, it's going to attempt to sign in. I am going to sign in as an Intune administrator, and I just so happen to be the global admin to my tenant. Again, it's a demo tenant. I'm going to sign in. I have MFA enabled with the Authenticator app, and everyone should follow this best practice. Actually, I think Entra is enforcing this now, which is a great thing. I'm going to go to my Authenticator app. Right? Again, remember, I've demoed this. This is recorded, so I've already done it. And now it's going to say, hey, are you sure you want to revoke all 5 of those certificates for that issuing CA object ID? Yes, I do. All right. So I'm going to hit yes. And it's just said you're going to walk through all the certificates of that issuing CA and go ahead and revoke them. Wonderful. Now I can go and essentially click on my issuing CA, and I'm going to hit the revoke button. It's going to say, are you sure you want to revoke this issuing CA? And I said, yep. Now, this is the part, Jack, that you can't go back, right? and it is revoked. So the issuing CA, and by the way, when you revoke the issuing CA, it updates the CRIL for the root CA that you have, right? And so now I can delete the CA, and voila, the CA is deleted. I'm going to refresh my list view here, and it is gone. So that is essentially the walkthrough. Hopefully, if you had any questions, you saw the process. We answered some of those questions through that process. Again, this is pretty well documented online as well, but when you see it firsthand, that always helps. All right, next, let's get into the SCEP certificate profile. Cloud PKI specifics, right? I'm not going to cover the entire SCEP certificate properties, just those particulars that are relevant to Cloud PKI. So a few things. The first thing is the subject alternative name property, right? So Cloud PKI adheres to this RFC that I've mapped out right there for Uniform Resource Identifiers, right? RFC 3986, okay? Essentially, we require when you specify a URI or any property type within the SAN, like DNS or email address, that it has to adhere to the proper syntax for that SAN type, right? And in particular, URI. URI requires some, a scheme followed by a colon with some value. If you don't have that colon in particular for URI, you will fail the issuing of the certificates, or the certificate will error out and you will not get issued to the device. ADF and Active Directory Certificate Server, again, it's been around for many, many years. It's not enforcing this particular RFC, right? The Azure security team required the Cloud PKI essentially adhere to that RFC, and so that's the reason why Cloud PKI requires it, but ADCS doesn't, right? So just be aware of that. We had a one or two customer reported incidents on this matter. To be honest, I have yet to document this, but it will be documented within the next 2 weeks, I promise. And I have to do it now that I've said it publicly. I'm on the hook. Next thing that I would just want to mention here, for the SCEP URL, again, when you have your issuing CA, that's a Cloud PKI issuing CA, one of the properties is this SCEP URI. The SCEP URI is essentially that MDES service in the cloud, that thing that you don't have to configure, manage, procure on-prem anymore. It's in the cloud. We host the whole service. We make it super easy for you. We put a specific variable within that URI. It's called Cloud PKI FQDN, fully qualified domain name. Do not edit, change, or do anything with that variable. Leave the variable as is. I'm going to give you a little background on that variable.
Wait, Bill. I got a question. Because it's my favorite thing in the Cloud PKI interface. Is this why there's a copy button next to that URL?
That is the reason why there is a copy button next to that URL. Nice. You copy that, and you can just paste that right into your SCEP certificate profile for the SCEP URL.
So beautiful.
Property. Yeah, it is pretty useful. Thanks, Jack. Anyhow, that FQDN, right, the Cloud PKI FQDN, that represents Intune uses what's called a traffic routing service, right? Long story short, if a tenant is on an overburdened scale unit and we have to move it, or a customer requests to move from one geographic region to another geographic region, or from one US-based region to another US-based region, for whatever reason, and it happens more often than you think, customers don't have to make any changes to the SCEP certificate profile. That variable essentially handles it seamlessly for the customer. So the next time the customer is requesting, the device for the customer's tenant is requesting a certificate, we know where in the service that SCEP service should be coming from, right? It's a very nice thing, and makes things much easier for customers, so they don't have to, if they move from one scale unit to another scale unit, they don't have to do anything. It's great. The last thing I want to mention is something called the extended key usage, or EKUs. Cloud PKI does not allow the any purpose EKU. It's not supported with Cloud PKI. There is a huge security issue associated with any purpose, right? Essentially, just a quick background here, any purpose, if you issue a certificate with any purpose, it can do anything, right? Meaning it can do code signing, it can do client off, it can do anything because there's no restriction placed on the usage of that cert.
That would even allow me to create a certificate authority cert, right?
Potentially, right?
Mm.
So it's anyhow. Long story short, Cloud PKI doesn't support it. ADCS supports it. Some admins create a policy on the ADCS environment to not allow any purpose, and that's actually a very, very good practice. So anyway, don't use it with Cloud PKI. You'll get errors. This next one has caused a lot of fun and activity for Jack and myself. First me, then Jack took over, and then it's back with me. So anyhow, I think this was in 2023 that the ADCS team released this. There's a KB article that came out.
Yeah, Bill, I'll actually correct you. It was May of 2022 in the Windows updates, is where that reference comes from.
Essentially, it requires a strong mapping to address certain, a scenario where there was potential certificate spoofing. And so the certificate that gets issued for client authentication has to have a SID identifier on it, right? There's more to this KB. There are other methods that are supported to adhere to this KB. And to essentially protect yourself from this vulnerability. But the way Intune is handling is essentially we're adding the SID to the certificate that gets issued. Jack, you want to just add some additional comments?
Yeah, no, I was going to say,
so much work on this.
Yeah, I think you've done a great job covering it. The key point of the KB is that there's an absolute mapping of an immutable property between the certificate and an Active Directory object, whether that be a user or a computer object. So by populating the on-premise security identifier, which is a property that gets generated on a domain controller, it allows that strong mapping. I think the other key point is there are changes coming to Windows where right now, by default, this is in an audit mode. They are planning in a future Windows update, I believe it's September of this year, that it will go from audit mode to enforce mode by default. And at that point, if you have certificates presented to a domain controller without these strong mapping properties, they will be denied. So something anybody that's using certificates and authenticating against an Active Directory KDC or domain controller needs to make sure they're covered by. And that support tip covers it well.
Great. Thanks, Jack.
Yep.
Just the last point I want to mention is Cloud PKI supports this capability. Mm-hmm. The Intune certificate connector connecting to your on-premise infrastructure also supports this scenario. So it's not just Cloud PKI, it's the Intune certificate connector as well, which, it's a great thing. All right, let's keep pushing on. Oh, the network policy server. Here we go, Jack. Let's talk about this very fun topic.
Yes. Now, you don't have on your introductory slide. What is NPS? What do I use it for?
Good, very good question and good catch on your part. So NPS is the Microsoft Network Policy Server. It's been around for many, many moons, and it's essentially a radius service, right? So when you want to authenticate with a certificate to, let's just say, a Wi-Fi infrastructure or a VPN infrastructure, you want to, when that certificate gets presented, a radius service will actually interrogate the certificate, see what's in see if it's trusted, and see what the subject name or subject alternative name details are, and then compare that with a trusted source. That trusted source in this case would be your Active Directory domain environment. That's what NPS can leverage. And so it will validate that the subject name of the certificate or the subject alternative name of the certificate contains an entity that is also present in this trusted Active Directory environment, right? If it is, then it says, okay, and obviously if the certificate is trusted, all the trust chains are in place, it will then say, okay, I will allow you in to access Wi-Fi or access VPN, etc. So that is essentially what the NPS service is. Did I miss anything, Jack?
No, I think you covered it really well. But back to our point of that strong mapping, that is NPS and Active Directory would be the one interrogating for that on-premise UPS or on-premise security identifier.
So first things first, right? So before we get into all the the particulars around NPS and Cloud PKI, so let's cover a few fundamentals that I think are really important no matter what, especially when you're dealing with what's called a relying party, right? So in this case, the radius service or any service that you're going to present a certificate to for authentication, that is essentially called a relying party. They rely on that certificate, and they become a relying party on the certificate to be authenticated. Okay, so where is your root CA? Remember, Cloud PKI has two deployments that we support. You can create a root in Intune, and you can create an issuing CA off that root in Intune, or you can create what's called a bring your own certificate authority, where you create an issuing CA in Intune, and then you anchor that issuing CA from Intune to a private CA. Most of the private CAs that we have or the customers have are Active Directory certificate server. So you can anchor our issuing CA from Intune to any portion of your hierarchy within your ADCS environment. It could be off the root, it could be off of another issuing CA, so it can be off the third tier, the second tier. It's really up to you and how you want to anchor it or where you want to anchor it to. So those are the two deployments, but you really should know where your root CA is, because that's going to essentially become the starting point for your chain of trust. And chain of trust is critical to a relying party in order for it to trust the certificate, to validate the certificate, to ensure that it was going to accept the certificate, to let them in the door. All right, so let me just go over the root CA deployment. And again, this is super helpful in general if you deploy, Cloud PKI with the root in the cloud, or Cloud PKI bring your own CA. And by the way, you can actually combine both. So you can have deployments where you have your root and issuing in the cloud, and also bring your own certificate authority issuing CA where that's anchored to your on-premise infrastructure. So very, very flexible. Okay. So the certificates here that I'm showing, the ones in blue, those are Cloud PKI, right? So you got your root, you got your issuing CA, and then I've got the issuing CA here. I'm sorry, the bundle of the certificates here, those two certificates, and I'm going to deploy those down to the device, right? And they get delivered to the device. Now, because the root CA is in the cloud, the relying parties, whether they're Wi-Fi, VPN, whatever they are, applications, they need to trust that chain. They need to trust the certificate that Intune is going to issue down to the device, right? And so if those relying parties don't have that trust chain installed on them, then they're not going to trust the Intune client authentication certificate that got issued to the managed device, and it will reject the authentication, right? And so that's the big deal here, right? So if you're going to do a root CA in the cloud and you're going to issue SCEP certificates to your managed devices, your relying parties that are on-prem have to have that chain, that trust chain of the cloud installed on them. That's the big key. Jack, do you want to add anything here?
No, I'm good. I'm going to give you a demo of this in a little bit, though.
Beautiful, beautiful. All right, the next one I want to talk about is bring your own certificate authority, right? Again, this is just a quick snapshot of what bring your own certificate authority actually represents. Remember, as I said before, that you create an issuing CA in the cloud. You're going to create what's called, when you set it up, you're going to create what's called a certificate signing request, and you're going to have that certificate signing request signed by your private CA. Any tier can sign it, and then you upload that signed certificate, and now into Intune, now you have your issuing CA that's trusted by that private CA. It's anchored, and it can issue certificates, right? Or it can sign certificates.
I want to cover one thing real quick. So you said any tier can sign it, and if I'm interpreting your diagram here right, there's 3 different tiers. So you're saying my cloud CA could be have it cert signed by, I don't know, what you have represented as an issuing CA?
That's correct. It would essentially become a sub CA of the issuing CA.
Great. So that'd be a 4th tier, effectively.
Effectively, correct.
Nice. Okay. Cool. Thank you.
Yeah, you bet. Good question. Bring your own certificate authority. So simpler deployment in certain respects. Remember that your device must talk to any one of these relying parties. How is it going to talk to that relying party? It's going to talk to the relying party over an SSL channel. Cloud PKI does not issue TLS certificates, right, to these relying parties. These relying parties are already using a TLS certificate. Perhaps it's more than likely issued by their private PKI, their private ADCS environment, right? So in order, these devices already, again, trust this private PKI, the managed device has to have that keychain of your private CA delivered to it. Now, this has to happen no matter what, whether you're using the Intune certificate connector or whether you're using Cloud PKI. This is what you're doing today if you use any one of those two services.
So wait, Bill, if I have a mixed environment, I've got some Intune managed devices and other devices that aren't Intune managed, are you saying BYOCA is probably the option I need to choose?
You can most certainly choose that option. Absolutely.
Nice. Okay. And then my devices, both Intune managed and non-Intune managed, can get access to Wi-Fi.
Correct.
VPN.
Correct.
Private PKI, TLS protected sites.
Yeah.
Nice.
Spot on.
Nice.
Spot on. So the deployment is simpler because, again, Cloud PKI is the issuing CA is already anchored to the on-premises infrastructure. So that trust is already established, right? And so all you have to do is deliver the keychain for your private CA down to the devices, issue the certificate from the bring your own certificate authority down to the device, and you establish trust automatically, right? It's a very simple deployment from that perspective, because the most complexity you're going to run into, and it has got nothing to do with this diagram, is essentially generating the certificate signing request in your initial setup for bring your own certificate authority, and then having that signed by your private CA. But
all right, so if I'm greenfield and I'm starting everything new, Cloud PKI root CA, perfect. If I'm brownfield, I've already got some environment and I'm gonna deploy Cloud PKI. Seems like this BYOCA option really does let me bridge the gap.
It does bridge the gap pretty nicely, and you can hit the ground running very quickly with the BYOCA. Right?
Great, awesome.
Okay, let's talk NPS. These are some specifics that people miss, so they automatically make certain assumptions about what works and what doesn't work. So super important to talk about this. Okay, so number one, for intra-joined devices, what was normally known as Azure Active Directory joined devices, meaning that the device is not present, the actual device registration is not present on in your AD domain. It's not a member to your AD domain. So Cloud PKI works with the user auth scenarios for NPS because the user, more than likely, the user has to exist in AD domain and Entra ID. But if you're pure cloud and you don't have a presence in an AD domain, a user doesn't have presence in AD domain, then user auth is not going to work for an NPS scenario. FYI, right? That is a super edge case. The other scenario is that you want to do device auth with Cloud PKI, a certificate issued for Cloud PKI to the NPS server, right? And in this scenario, because it's an AADJ only device, the device object does not exist in the AD domain. Hence, this scenario will not work for NPS. You can't do a device auth with a device to NPS that doesn't exist in AD domain. It's pretty obvious.
Wait. Does this go back to that on-premise identifier that we were talking about earlier?
That does go back to the on-premise.
Goodness.
If a device does not have a SID, a security identifier, because it doesn't exist in the AD domain, then obviously you can't issue a device certificate with a SID that doesn't exist. So you can't do a device. It just won't work. Now, you can do the user scenario, no problem.
Nice. Awesome. Thanks, Bill.
All right. Okay, hybrid joined Entra devices. So again, because the device and the user are present in both AD domain and Entra, both user scenarios and device auth scenarios work. Okay? All right. Jack, I'll let you take over the slide.
Great. Thanks for handing it over to me, Bill. I'd start out with my environment. So I've got a Cloud PKI with a root certificate authority and an issuing certificate authority. And what I really wanted to show is a tool called PKI View. If you're not familiar with it, pkiview.msc is the program that you can run. And so we were talking about that chain of trust and how do I get my Active Directory to trust this issuing CA? So by default, I have some on-premise certificate authorities, and those are what we see in the list here. I've already exported my Cloud PKI one, so I'm going to go ahead and go into this tool, manage my Active Directory containers, and add first my root CA, and then I'm going to add my issuing CA. Open that, and as soon as I save this, voila. Now my on-premise Active Directory will trust those as authenticating authorities. And again, that was in managed AD containers and NT auth certificates. So pretty straightforward, relatively easy task. One other thing I'll jump to real quick, Bill, if you don't mind. Is wanted to show, we were talking about the how do we add that on-premise security identifier to a SCEP profile. So here's an example of a SCEP profile. I have it defined. It was as simple as you pick that I want to do a URI property and then fill in that variable of on-premise security identifier and save that, and that will have Intune issuing that on-premise security identifier attribute that's called out in the support blog to your devices and users. And pretty much that's it.
Again, Jack just gave us a nice demo of the MPS walkthrough. It's pretty straightforward, and to be honest, we should add some documentation online to just cover the MPS scenario, how to do it. Pretty straightforward, but if you don't know what to do and you don't know what scenarios to support, I can appreciate the pain, and so I'll be taking an action to get that updated online documentation.
Thank you, Bill. Much appreciated.
You got it. I've got some action items from this Tech Takeoff presentation. All right. So next, what I want to do is today there is a limitation of how many certificates get displayed. If you have in that leaf certificate report I showed you previously. If you have more than 1,000 certificates, we won't show you anything past 1,000. It's painful, but if you went into an alternative traditional certificate report that we have, that limitation doesn't apply. We've addressed the issue, right? Thank goodness. And so I'm pretty sure that in the next release of Intune, the next sprint, this expanded leaf certificate view is now supported. So there's no longer that limitation. We actually implemented it as an infinite scroll. Let me just quickly show it to you. Although I don't have a CA with 1,000 certificates or over 1,000 certificates, but I do have one with a few certificates, and you can actually get a feel for how it's going to behave. So I'm in a different tenant than I was in before. Here's my issuing CA. I'm going to click on it, and it's loading up here. You'll see here that it's got 661 certificates that are active. And so I'm going to click on the view all certificates. That's going to give me what's called the leaf certificate view. And there you go. I've got, obviously I can search through here, but this is implemented using the React UX Java interface. And so that's how it's implemented as a non-paging, but more of an infinite scroll. So once you reach the first page, it will actually load up the second page. You can keep loading, right? You can keep scrolling down, and it continues to load up each page accordingly. And you can obviously search. When you search, it will just go right to the item that you're intending to find, right? So pretty simple demo, but we've addressed the issue, and it was a needed update. Let me go back to the presentation to wrap things up here. All right, so we just did those two demos. And so now let me just quickly cover what's coming, what we have that we'd like to deliver in 2025. All right, so these are the things that we feel like, pretty good about. So number one is providing the Cloud PKI service to our government cloud high customers. And so that's something that we're working to do, hopefully in the second half of the year. And then we are planning, I don't have any specific time frame to share just yet, though we are planning on supporting post-quantum cryptographic support for our certificates that get issued through Cloud PKI. And then I just showed you the leaf pagination support that addresses that 1,000 certificate limitation in the console. So those are the things that I can share with you at the moment in time.
And Bill, I cannot wait to hear more about post-quantum computing cryptography support.
Yeah,
I'm on the edge of my seat on that one, buddy.
You got to be a nerd, Jack. I'm a nerd. Trust me. I love PQC. All right. So thanks, everybody. Hope something was useful for you. Hope you got a little bit out of this session. If anything, you were slightly entertained with Jack and myself.
Great seeing everybody today, and I hope you're having a great day.